Hello everyone, welcome to the next class on the two-dimensional distribution functions. So in this class we will discuss about what is the continuous random variable, how we can solve the marginal and the conditional distribution for this two-dimensional random variable. Myself Dr. Garg, working in the School of Mathematics, Thapar Institute, India. You can contact me, either of my email IDs are there, or else you can simply follow this YouTube channel link for find the various updated videos. So first of all, what is the two-dimensional variable, and when what is the condition that you can set to be a continuous here. So a two-dimensional random variable x and y is said to be the continuous provided there exists a non-negative function f such that this is the non-negative function f such that for any pair of the x comma y you have satisfied this condition. So where capital F is nothing but my distribution function, and all of you know that in the one dimension problem you have defined this as from minus infinity to x of the PDF. So same thing we can define here. So since there are the two variables x and y, so we can define here, and this small f, that is a function, is called as the joint density function provided these conditions holds are there. That is a function which is a positive value and their total integration is a 1. So you can take either as a dy dx or you can take as a dx dy. That is a same problem is there. Once you have this, then what is the meaning of the marginal density function? So since you have the function of the x and y, so your target is to construct a function from this x comma y which are totally depending upon the x, and the function which are totally depending upon the y. So if you find the function which are totally depending upon the x, that is called as the marginal density function of the x. On the other hand, if you construct a function of y, like if I say if my function is here, so I can write this function simply in form of here. So it means this is the marginal density function of x, this is the marginal density function of the y. Similarly, if I write here something over x minus y, then it's not an easy to write to separate x and y easily. So for that we define the marginal density function of the x, which is denoted as a fx, over the y as a fy. So what is the definition is, this is the collection of all those y's are there. So that is, you have to find the collection of all those y's. So that is the integration of y. Similarly, if you calculate the x or marginal density function of y, so it means collection of all those x are there. So once you are calculating the marginal density function, then the question arises is how you can find the conditional density function. All of you know that what is the conditional probability of A intersection B is probability of A condition B is A intersection B divided by P of B, whatever you have written here. Same for here, the function of x and y divided by this. So this, the numerator is called as the joint density function. Now look at that, the function of fy which is dependent only on the y. So this is called as the marginal. Similarly, you can find the marginal of y condition x, this is there. When you can set to be the independent, so since you have this function here, you have to compute the marginal density function of x and y here. So if you check this condition holds, then you can set this variable x and y are independent. So let's discuss some 4 or 5 examples are there. So in order to solve them, so always remember that tips, you have to firstly draw the feasible area and then you have to calculate the limit. So I have to use these 2 steps for each of the problem. So look at that, what is the my feasible area? So whatever the statements given, that's a very simple. What you have to do is you have to firstly draw the graph of whatever the domain you have given. So you have to draw the graph of this. So that is this is my x, this is my y. So what is the x is 0? This is my line x is 0. This is my x is equal to 1, y is equal to 0. That's this line is my y 0, and this line is my y is equal to 1. So since what is the feasible area is here, so this is my feasible area. So you have to always draw this feasible area, irrespective of this, whatever written as here. So this is there. Now then you have to think about this. So the value of k. So it means in order to find the value of k, and it is given that this is the joint density function, and make sure that since there are the 4 parts, so for each of the part you have to draw separately this figure. So you start from this first part, the integration of 1 is. Now how you can find the limits? Always remember, whatever you have written here, that is outside limit, it will always give to the maximum and the minimum, while the limits of the inside will always be taken upon the strip. So look at that, you have taken on the x. Firstly you have taken the x, so you have to take this strip on the x-axis. What is the value of x here? 0. What is the value of this line ending at here? What is the value of x here is 1. And this is the outside of the limit y. So in this figure, what is the minimum value of the y? This is the minimum value of y, 0. What is the maximum value of the y here? 1. So this is the 1. So the limits are my here. So once you are substituting the value of the fxy, that is the kxy, you can substitute the value here. And since you can integrate this like this way, so firstly with respect to x, you can take as ky constant, then x square by 2 and so on, but there is no problem. Since the limits are my constant, so you can apply the shortcut tricks. So since limits is constant, so you can directly integrate both at the same time, x square by 2, y square by 2. Take the limits as here. So remember, this rule is applicable only when the limits are my constant, so you can directly take them. So once you substitute, k is my 4. Now how you can find the marginal density function? So since in order to find the marginal density function, it means you have to find the function of the x only. So it means the collection of all those y's. So and similarly, if you find the marginal function of the y, it means collection of all those x. How you find the collection of all those? Now this is the y, so you take the strip over the y. So this is the my y-axis. What is the limit of the y here? This is 0. What is the limit of the y here is 1. So the marginal density function of x is my 0 to 1. Similarly, if you want to take here, this is the marginal density function of the x. So you have to take the limits on the x-axis. What is that? This is 0. What is that? What is the limit of this is 1. So this is 0 to 1. Anyhow, so we can try to solve them. This is the value of the kxy of dy. So since this is over the y, so kx is my constant, so you can solve them. You will get here, k is my 4, you will get this value. Similarly, on this value, so in order to find the limit on the x-axis, so you can take the limit of the x-axis 0 to 1, substitute the value as here, you will get this marginal here. So therefore, what you get is, you have the function kxy, you get the marginal of y, marginal of the x. Are they independent? So what is the condition? You have to check that whether this is true or not. Yes, this is true. So you can see that this is the independent. Now, if you want to find this, again, you have to remember that this is my original figure. So in this original figure, you have to draw this graph firstly. X plus y is 1. So this, what is the limit of this? This is the graph of the x plus y is 1. Now this is the portion of the less than 1. So what is the feasible area? This is my feasible area. Now how you find the probability of this? Now since this is the function of the x and y both, so that's why you have to take the double integration, either dy dx, or you can take the dy dx, or else you can take the dy dx, or you can take the dx dy. That's depending upon you. For example, if you want to take the dy dx, so it means the firstly you have to take the limits on the y. So y means you have to take the strip on the y-axis. What is the limit of here is 0. What is the limit of here? What is the value of the y on this line, red line? That is the y is nothing but my 1 minus x. So this is my 1 minus x. And the outside limit are always be the minimum and the maximum. So this is the x. What is the minimum limit of the x is 0. What is the maximum value of the x here is 1. So this is the limit corresponding to them. On the other hand, if you want to take a limit on this side, so this is the x side. So firstly you have to take the on the x-axis. If you want to take on the x-axis, so you have to take the horizontal strip. This is my 0, and this is my, what is the value of the x here is 1 minus y, and outside limit is y. So what is the minimum value of the y here is 0, maximum value of the y is my 1. So again 0 to 1 here. So rest is the simple. You can substitute the value of the, this is my kxy, that is nothing but 4xy. You can substitute the value here. Now make sure that this is not be equal to like this way, x square by 2 and y square by 2, because the limits is not a constant. So how you can solve them? You can simply take the integration of with respect to y firstly. So 4x is constant. You can substitute the limit here, and after that you will get here. Look at the next example here. What you can do is, again you have to firstly draw the feasible area of this. So what is that? You can draw like this way. What is the common portion is this? X plus y is less than equal to 1. So this is my feasible area. Now how you find the value of the x is, you have to take the limit of dx dy, or you can take dy dx. So if I just take the dy firstly, so you have to take the strip on the y-axis. This is nothing but my 0. So the limit is 0. What is the limit of the y here? What is the value of the y here is? You can take from here. This is nothing but 1 minus x. Outside is x. So what is the minimum value of the x is 0. Maximum value of the x is my 1. So the limit is my 0 to 1. So you can substitute the value of the fxy, nothing but the kxy. You can substitute value here. Again, you can't, because limit is not constant. So you have to solve it manually. You will get as a 24. In order to find the marginal density function, again the definition is same. So this is the original figure. Okay, so in order to take the marginal of the y, so you have to take the strip on the y-axis. What is the value of the y here is 0. What is the value of the y here is 1 minus x. So the limit is my 1 minus x. You can substitute the limit here. You can similarly for the y-axis, x for the marginal of x, you can take the limit on the x-axis. So this value is my 0. What is the value of the x here is nothing but my 1 minus y. So limit is 0 to 1 minus y. Once you take the limits are correctly, and then you have to simply integrate them. Now this is a function of the x. What is the minimum value of the x is 0. Maximum value is 1. So limit is my 0, 1. Similarly, you can substitute the value of the fxy here. What is the minimum and the maximum value of the y in this limit is 0 to 1. Now you can check whether they are the independent or not. So what you can do is you have to check whether this condition holds or not. So you can clearly see that the product of this is not equal to this. So it means they are not independent. In order to find this probability like this way question, so what you can do, this is the original figure. In this original figure, you have to draw the graph. X plus y is less than 1. So when this is my half, this is my half. So if you draw like this way. Now the portion is the less than of the sign. So what is that? This is my common portion is here. So this is my common portion. So now since this is the function of the x and y both, so you have to take the double limits. So you can take either dy dx or you can take the dx dy. So if I just take the dy firstly, you have to take the limits on the y-axis firstly. This value is my 0. What is the value of the y here? So y is my half minus x. So this is my half minus x. And what is the limit of the x here is? What is the minimum value of the x is 0. What is the maximum value of the x here? This is the coordinate is my half comma 0. So the limit is my 0 to half. You can take. So sorry, this is my 0 to half. So once you can substitute the value here, 4xy, that's 24xy. You can substitute the limit here. This is there. You can substitute the value. You can solve them. You will get the required answer. Look at the third example here. Again, you have to firstly draw the feasible area of this one. So how you can draw that? You can simply take the axis. X is equal to 0, x is equal to 1, y is equal to 0, y is equal to x here. Now which portion is the feasible area? So you can take any point here. So this point is say my 0, 3. Whether this 0, 3 satisfy here, you can see 0. This is not satisfied. So it means this portion is not be the feasible area. So only portion here is this is my feasible area. Now you have to find the value of the alpha. So again, this is the PDF, or this is the JDF, joint density function given. So you have to calculate the value of dy dx. So if I take the value dy, so you have to take the limit on this. What is the value of here is 0. What is the value of the y on this line? That is here, y is x. So 0 to x. What is the minimum and the maximum value of the x in this case is 0. What is the coordinate of this is 1, 0. Coordinate of this is 1, 1. So this is nothing but my 0 to 1. So you can take here. Substitute the value of the fxy is alpha. You can integrate them. You can simply integrate. This is the required answer. How you can find the marginal density function of x? So this is the marginal of the x. It means the collection of all those y's of the fxy. So in order to find the collection of all those y's, so you have to take the limit on the y-axis. So this is a 0. This is my x. So that is a 0 to x. If you want to find the marginal of the y, so collection of all those x. So take the limits on the x-axis. So this, what is the limit of the x-axis here? What is the value of the x here in this line? Y. What is the value of the y here is 1. Look at that. This is 1. So the limit is my y to 1. So once you will get here, you can integrate them. Alpha, so alpha x, so limit minimum and the maximum. Again in this case it is a y to 1. You can see this value is my y, this is by 1. You can integrate the value of the alpha. This is the required answer. Again you can check whether they are independent or not. So check whether f of x into f of y, are they equal to this? So this is fy, this is fx, they are not equal, so it means they are not independent. How you find this value? Now you can see that this is the function of only x, so it means there is a need of the only one x, one integration of this. So remember that in the last example what we have discussed, that if we calculate this value, so this is the function of the x and y both, that's why we take the double integration. But here the function of the x only, so means we have to calculate only for the f of x. So what is the meaning of that? This is the function which is depending only on the x. Okay, so function which is dependent only on the x, that is called as the marginal density function, and we already calculate the marginal. Anyhow, we will draw this graph into this one. This is the original graph. So x is 1/4 here, so this is this one, so x, this is less than, so what is the common portion is, this is nothing but here. Now in order to find this, you have to take this. So this is the function which is dependent only on the x, that is a marginal density function of the x. So we already calculated the marginal density function of the x. So now in this case, this is the over the x, so this is the limit from here. Now since this is a function of x only, so there, it means there is no need of this step, because this is the single one dimension variable. So we already calculate the marginal density function, we can substitute the value, we can get as here. Alpha we already calculate, we can substitute the value here. How you find the conditional density function of y given x? It means you need to calculate here. So what is the definition of this? This is y comma x upon here. So you can see, you can calculate here. So what is that? This is the joint density function. And this, what is the meaning of this? The function which is depend only on the x. What is the function which is depend only on the x? That is called as the marginal. So we already calculated the marginal density function of the x and y. So we can substitute the value here. This is the alpha. What is the marginal density function of here? This is alpha x. So if in some cases it is given that x as my half, so you can substitute the value of x as a half. But here this is nothing is given here. So the answer is here. Similarly, you can find the marginal density function of the x when here you can calculate using this value. You can substitute the here. This is the marginal density function of the y. You can substitute here. Look at the last example. Now in this case again you have to draw the firstly the feasible area, because it's a two-dimension problem. So this is the feasible area x greater than, so this is here. Now in order to find all this portion, look at that. This is the only for the x, so it means the answer is my here. This is the expect, this is the single x, so it is my here x into fx. This is again single y, so this is y into f of y. Here is xy both, so these are two variables, so I can take as a double summation xy of function of the x and y. Again here the two variable x and y, so I can take as a two variable two summation function of the x and y here. Now how you can find this f of x? So you can see, what is the f of x? A function which is dependent only on the x, it means it is a marginal density function. Here is also the marginal, and so on. But while here this is my joint density function. So in order to solve this, this and this, we need to find the marginal density function. So we will firstly calculate the marginal density function of x. So how you can find that? This, okay, so collection of all those y. So y limit is my here, so this is 0 and this is my infinity. So once you integrate them, you will get as this is my limit. Also marginal density function of y you can take on the x-axis. You can take on the x-axis here, this is 0, this is infinity, so you can solve them. Also in other words, you can simply write this term as here. You can simply separable this term, so this is marginal density function of the x, this is marginal density function of y. Now check whether they are independent or not. You can simply see that f of x into f of y is nothing but my f of xy, so this is my independent here. Now you can try to solve them. So what is that? This is nothing but my 1 to infinity of f of x dx. So this is the marginal density function of the x. So you can substitute the marginal density function of x here. You can integrate them, you will get here also. Similarly, you can calculate the mean of this x into f of x. That is again the marginal density function. You can substitute the value of here. You can simplify, you will get 1 here. Again, you can calculate the mean of y into f of y. Now this is the marginal density function of y. So marginal density of function of y here. You can substitute the value here, you will get here. Now here this is the function of the x and y both, so that's the double integration xy f of xy dy dx. So remember that I have used in the previous one this I can move back as a summation if this is for the discrete case. If it is a continuous, then we can replace this summation as my integration. So we can calculate this limit as there. So basically there are the two ways. To calculate the e of xy. The first method is we can start from here, okay, and after integrating you will get this result here. Second method is that since we have proved that x and y are independent, so we can write this term is directly here. So ex ey is 1. So remember, this result is applicable only when x and y are independent. But if x and y are not independent, then you can't write like this way. But in this example they are independent, so you can write directly here. And the last part is how you can calculate the e of x plus y. So you can write ex plus ey. This is the first method. Else how you can write, since this is a function of the x and y, so you can take the double integration of x plus y f of x comma y of dx dy or dy dx. So you can take the limit as from the figure here. So once you will solve, again you will get here. So but if you want to know this result, you can simplify that. So this is the way you can solve that. So we will see more examples related to this joint density function, how you can find the mean, variance and or in our next class. Till then you can simply follow this link. You can share this video to your friends. Best of luck students. Happy learning.